Good morning, everybody. My name is Richard Hukla. I'm the director of the Energy and Earth Resources graduate program here at the University of Texas. It's my pleasure to introduce this session and the second day of Energy Week. I'll speak to our panelists at the very end of my introductory presentation. So if I could have the first slide. I'm introducing the first panel this morning, which is in the second day of this UT Energy Week presentation. So we're going to be talking about energy leadership, and really we're going to be focusing on corporate leadership here with the representatives we have. I'll introduce them at the end of my introductory presentation. So next slide, please. All right, this is one perspective that I'd like to offer you as to how investors see the future. And on this slide, what I've shown is market cap. I got these pre-market yesterday morning. And what I can show you here is that the market currently looks at Tesla as being only about $80 billion short of the value of all the super majors combined. It looks at Tesla as being almost 3 times as valuable as Toyota. Toyota produces about 10 million cars a year. Tesla may get to 700,000. And then Alphabet, of course, is about double the size of all the super majors combined. My first reaction in looking at this is the world is barking mad, but this is what the investor community thinks. Note that the investors are always thinking forward. Today matters little, the past matters almost none at all. And the investors are very important part of the energy transition. Next slide, please. All right, I've titled this slide, "The Future Ain't What It Used to Be." Energy demand has changed a lot over time, but there have been some fairly consistent upward trends. The future does indeed look quite different. And what I'm showing you here are a whole series of energy outlooks, a good number by oil companies, but also by the IEA and by a consultancy, Wood Mackenzie. I've shown superimposed on this the 2 recently announced BP scenarios, net zero and rapid. And I presume the Shell net zero scenario is going to be pretty close to this one. On the vertical axis is oil demand in millions of barrels. If you're a company looking to the future, there is an enormous range of uncertainty that you have to contemplate as you're thinking about the targets that are going to get us close to the 2 degree criterion. I'm going to point out this dashed blue line, which is the Wood Mackenzie carbon constrained scenario, which doesn't quite make the 2 degree criterion, but gets pretty close. And let's look at it on the next slide. So here it is. These constraints are certainly achievable, but they're not a gut cinch. 40% of power, for example, will be met by wind and solar in 2035. That's globally. Now, if you buy into this scenario, fossil fuels still provide 75% of energy in 2040, about 80 to 85% in 2018. So again, if you believe this scenario, if you're planning for the future, the greatest CO2 benefit will come from mitigating emissions from fossil fuel combustion. I know we're going to hear a little bit about that later today. Next slide. Now, what is the process that corporations go through as they think about what they're going to do next? Well, they consider the overriding issue. Climate certainly would be on the top of the list. They look at short-term impacts, very significant impacts, maybe black swans like COVID. They look at local politics, say the Trump to Biden transition, and they assess geopolitics as they might affect things like supply chains. And so in each one of these cases, they're assessing a series of trade-offs as they choose between fossil fuels and renewables, and out of that comes a decision. It's very important to point out that these companies are not just along for the ride. Their goal to protect their business is to actually enable the future. Next slide, please. Now, key considerations for any one of these companies in coming up with sustainable energy solutions is that they have to be based on sound science and technology. They have to be consistent with policy, which adequately addresses the welfare of society, and they have to be financially viable and to attract the interest of investors, as we highlighted in the initial slide. And these are the 3 tracks of our program, our Energy and Earth Resources program. This is my shameful advertising of the program as a multidisciplinary approach to addressing these sorts of issues. Next slide. So aside from all of these complexities, there are certain cognitive biases that stand in the way of our thinking about the future. Our intuition about the future is linear. This is my favorite futurist, Ray Kurzweil. What I've shown on here is a chart from Bob Margolis. On the vertical axis, it shows cumulative electrical PV capacity. This is global. The dark line indicates what's actually happened, and the lines, the colored lines, indicate projections at any time, outlooks at any time. So what I'll point to, for example, is that in 2012, the outlook for 2019 was that there'd be 280 gigawatts of solar PV capacity. The actual is 720 gigawatts of capacity off this chart. Next slide. The developing world plays a special role in this whole story. And on this chart, on the vertical axis, you can see the percent of US energy mix over time, basically since the start of the Industrial Revolution, as we moved from wood to coal to oil with the transportation age, and natural gases. We're more focused on cleaning up our power stack. Each one of these transitions has taken 40 to 50 years. And what I've shown on here is where China and India sit today as regards their energy stack. So are they going to have to endure this very long transition that we did, or are there technologies that will leapfrog them ahead? So energy is really complex because the problems are global, but the drivers are certainly local. Next slide. The capacity to change. As we look at these old established companies like ExxonMobil or Shell or Toyota, how capable are they of changing? Well, I will suggest that the intellectual heft and all sorts of other capabilities are there to do a lot. This is an ad from 1977 from Exxon at the time. And 1977 happened to be the time Exxon co-invented the lithium-ion battery. But at this time, Exxon was funding very groundbreaking research in solar PV. And I urge you to read the story of Elliot Berman and the Solar Power Corp that you can find on NPR. So the capacity to change is there. Next slide. And it's our last slide, where I'd like to end up. We're going to talk about a whole lot of issues, but we're on a university campus. We have students and their faculty who are preparing to be the energy practitioners of the future. And I'd like to reserve time at the end of our discussion to talk about that. The speakers, I'd like to introduce them in the following order, and they're by essentially corporate seniority. Ajay Mehta is the New Energies Research and Technology General Manager for Shell. Shell was founded in 1907. Jeff Makarowicz is the Group Vice President at Toyota. Toyota was founded in 1937. And Rayford Smith is the Director of Supply Planning for Analytics, Energy, and Water at Google. And Google's our fledgling, founded in 1998, worth about 4 times Toyota and Shell combined. So with that, thank you, panelists, and I'll turn this over to Ajay.
Great. Thank you, Richard, and I hope that you can all hear me. Delighted to join you here today at UT Energy Week. If I can have the first slide, please. I'm trying to spend the next 5 or 7 minutes just kind of framing the issue from a Shell perspective on what would it actually take to build a net zero energy system by 2050. Since this is a kind of a Shell presentation, I do have to start with the inevitable disclaimer slides. If I just quickly have the next slide, please. Just kind of, since I'll be making a few forward-looking statements, I need to kind of emphasize that please don't construe anything that I say to be incentive to buy a Shell stock. And then there's a whole bunch of other legalese written in there. So then without further ado, what I'd like to kind of start with is kind of state what is the corporate ambition? What is Shell's ambition? Could I have the next slide, please? The broad Shell ambition in the climate space is that we intend to become a net zero energy business by 2050 or earlier. And the only way we are going to be able to get there is if we first start with kind of taking a look at our own operations and how do we achieve a net zero, emissions footprint within all of our existing businesses and operations, whether it be upstream integrated gas, chemicals, downstream, the new energies business, etc. The second part is that we are very much aligned with the goals of the Paris Agreement, and indeed we will even go further and say that the world needs to be thinking in terms of how can we achieve a 1.5 degree C ambition, let alone the 2 degree C ambition, which is aggressive as a target, but it is doable. The
Hey,
only way
Ajay,
yes,
if I could interrupt for 1 second,
of
you were
course.
very hard to hear.
Okay, sorry about that. Let me see if I can try to speak a little bit louder, so hopefully you all can hear me a little bit better. So the second piece that you see in there is around how do we get to this 1.5 degree C, and that's going to involve us having a dramatic lowering of the net carbon footprint, both the so-called Scope 1 and Scope 2 emissions, as well as the Scope 3. So Scope 1 and Scope 2 emissions relate to kind of what does it take to actually generate the energy and get the energy to the end customer. And the generation side typically accounts for about 15 to 20% of the total energy requirement, or the net CO2 footprint that emanates from that. The biggest footprint is coming in from the end use of the product, the so-called Scope 3 emissions. So what I was saying is that yes, in order to achieve a 1.5 degree C ambition, we need to kind of look at both Scope 1, Scope 2, and Scope 3. And Scope 1 and Scope 2 emissions relate to those that get generated because of the production of the energy in itself, and Scope 3 is with the end use of the products. So when we think about our overall ambition on how we're going to achieve net zero, we are looking into Scope 1, Scope 2, and the ambitions generated by the end use of the products that we develop, or whether it be products that we generate ourselves or products that we sell, that we get from other customers. All of that is in that 80 to 85% of the Scope 3 emissions. And the third piece is that the only way you can achieve a net zero world is if it's not just that our own businesses get to a net zero, but also the end customer is also aligned with achieving a net zero in the end use of the product. So it's a very kind of a complex chain of events that needs to come together, but we truly believe that this can be done. So how will we achieve this? If I could have the next slide, please. Is that it's going to require a fundamental change in kind of how energy is produced and consumed. And there are three specific things that I want to just briefly touch upon. The first is we need to kind of see a massive acceleration in kind of, clean energy technologies. You're going to see a huge upsurge in electrification, and that's going to essentially, pace the rate at which this transformation happens. We are also looking into a significant uptick in these low carbon fuels, both in the hydrogen space as well as in the bioenergy area. Secondly, energy efficiency improvement is not just kind of a one-off thing. It's kind of a relentless focus on energy efficiency improvement. But alongside that, we absolutely believe in the need to have a carbon price. And that's something that really gives a lot more kind of certainty to businesses to make the kinds of billions of dollars of investments that it's going to take to make this transition. And the last part is that there will continue to be an acute need to do carbon capture, utilization, and storage at scale. And yes, the nature-based solutions will play a significant role in that in the near term, but carbon capture and storage is something that has to go hand in glove with any scenario that you can foresee. So just if I could have the next slide, please. The next couple of slides are essentially going to just reinforce some of the points that I made. But if you look back historically at the rate at which electrification has kind of penetrated the energy system as a whole, then it's been growing at a rate of about 2.5% per decade. We're going to have to take a look at about a 1% increase per year. So you're looking at a five-fold increase in kind of the rate of electrification as we move towards this new energy system of the future in order to achieve a net zero world. A second area, the next slide, please, that we have been, of course, a very patient investor in is in the area of hydrogen. And we truly believe that the stars are now aligned for hydrogen to really take off. It's always had tremendous amount of promise in this space, but now finally things seem to be coming together with national governments putting in hydrogen economy-based roadmaps. There's clearly an appetite from the consumer and from the customer end, which wasn't present in the past. And we can think about end uses of hydrogen in a number of different cases for large-scale industry, for power generation, for transportation. There's all kinds of end uses of hydrogen that are really beginning to pick up steam. And one of the areas that we are looking at, especially from a transportation segment, very clearly is around the heavy-duty transportation, where we don't believe that the game is over with batteries being the winner. Light-duty vehicles, perhaps the game is over. And it'll be interesting to engage in the conversation with Toyota on that point later. But certainly for heavy-duty vehicles, we do see a huge opportunity for hydrogen. The next slide, I've kind of have just again alluded to this point earlier, where we clearly see a need for a carbon price, regardless of which tool or mechanism that you believe in. A carbon price allows us to kind of have that business certainty to be able to make that sort of an investment. And we do see a year-on-year increase in kind of what that carbon price might be. That in turn can enable us to make some of these investments that are going to be necessary. And the last slide talks about the next slide, please, talks about the CCS opportunity. Currently, there's less than 40 CCS projects going on around the world. There's going to have to be a massive step up in the CCS, and this is not something that is waiting for technology, to be invented. We know how to do this. We just have to kind of get the right sort of public-private partnerships to be put into place, the right sort of incentive structures to be able to do this at scale. And we're going to need to be investing in kind of a new CCUS plant coming up at a frequency of, a new plant of up to 8 million tons capacity every quarter for the next 30 years out to be able to get to a net zero world. The next slide just kind of summarizes our latest scenario thinking as we think in terms of how the different worlds might possibly unfold. I won't go into this in a lot of detail right now, but if you take a look at the first two aspects where we say that in a post-COVID world, people are going to be largely looking at economic recovery and resilience is going to be measured in terms of economic well-being. Then with that potential scenario where we're thinking about wealth first, we can get to kind of a point where we are going to bypass that 2 degree C, ambition that the world has for itself. If you look at a scenario in which security aspects end up being dominating, then again, self-interest in that arena with more kind of an island mentality could end up ruling the roost, where we could exceed even the 2 degree C target even further and get to a 2.5 C world, versus a sky scenario world, which is the one that we truly advocate, where you can truly put together all the elements together from a technology perspective, economic perspective, to be able to bring together what's required to actually make that curve into getting to a net zero world earlier than later. Even in that world, there's going to continue to be a role for conventional fuels to be part of that energy mix as we make that shift towards renewables, regardless of, again, which scenario you believe in. So to summarize in the last slide, next slide, please. I truly believe all these elements could come together with investment in low carbon fuels and technologies, build out of that full-blown energy infrastructure. All of us in Texas have lived through the recent winter storm and seen kind of how much of an acute need there is to be thinking many decades ahead in what this infrastructure is going to look like in the future, of a true focus on the hard to abate industry sectors, cement, steel, etc. What's it going to take to come down on the on the CO2 emission profile for those heavy industries, along with kind of enlightened policy and alignment with businesses, and not losing sight of the fact that all this has to be done with a clear eye on this being a fair and equitable energy transition for the future. So I'll stop there. Again, apologies for my audio hiccups, but hopefully you could capture most of that. So back to you, Richard.
Yeah, I think we got you most of what you wanted to say, Ajay. Thank you very much for your participation. I look forward to the discussion. I'm going to pass this over to Jeff, who's going to introduce Toyota's perspectives.
Yes, thank you, Richard, and good morning, everyone. Again, my name is Jeff McCarowitz, and I'm the Group Vice President of R&D at Toyota's North American Technical Center here in Ann Arbor, Michigan. But actually, I was just assigned to our corporate strategy and planning office at our headquarters in Plano, Texas. So I'm polishing up my cowboy boots as we speak, and I'm planning to move down to Texas next week to start my new assignment. That said, I sincerely appreciate UT Austin's invitation to participate on today's panel to share a little bit about the changes occurring in the auto industry, and more specifically here at Toyota. Now, to say that the automotive industry is undergoing a transformation would be a huge understatement. New technologies, new competitors, and new business models are radically changing the way that we think about mobility. Next, please. So how is Toyota preparing to change? Well, back at the 2018 Consumer Electronics Show, our global CEO, Akio Toyoda, made the following declaration. It's my goal to transition Toyota from an automobile company to a mobility company. and the possibilities of what we can build in my mind are endless. I'm determined to create new ways to move and connect our customers, whether it be across the country, across town, or just across the room. Now, Akio's comments were intended to be a challenge to every member of our company, and we're backed by significant investments in research and development and supported by a global restructuring that has made us more efficient and agile. Next, please. Now, predicting the future is extremely difficult. Right now, the conversation in our industry is full of a lot of hot technical trends and buzzwords, and I'm even going to use a few of those buzzwords today. Everyone's looking for the next big thing and trying to get ahead of the game. However, for us, transitioning to a mobility company means finding better ways to move people, goods, or even information. And at Toyota, we think the best way to understand this future is by studying changes to society, changes to technology, and the trends that follow from the interaction between the two. Next, please. And while no one can predict the future of mobility, we believe that it'll be shaped by 4 major disruptors or megatrends, which conveniently come together in the acronym CASE, which stands for Connected, Automated, Services, and Electrification. So let me take a moment to briefly explain each one. Next, please. The rise of ubiquitous connectivity is building toward a world where virtually all information is digitized, organized, and immediately accessible. Across sectors, we see a rise in technologies that generate large volumes of data through advanced sensors and wearables that's transmitted over universal Wi-Fi and collected and organized into an Internet of Things. You know, today's vehicles are continuously generating data, over 500 attributes every 200 milliseconds, captured real time from a vehicle's CAN network and sent to our data collection center via the DCM or data communication module. That's 7.2 million data points per connected vehicle per day. The use of this data is unlimited, and we're already seeing a rise in mobility businesses built on the integration of vehicles and connectivity. And the future offers much more. For lack of a better term, a fully functional, smart, and clean city will be able to bring together infrastructure and vehicles that can work together in the service of dramatically reducing congestion and improving personal mobility. Toyota has already broken ground on Woven City, an actual laboratory at the base of Mount Fuji in Japan that will create a fully connected and sustainable ecosystem. Next, please. The second disruptor is automation, because these intelligent, connected mobile networks are going to be supported by the next generation of artificial intelligence and automated driving technologies. Of course, the opportunity in vehicle automation is more than just a future level 4 or level 5 self-driving car. In the much nearer term, the lessons we're learning are being deployed in today's vehicles through the advanced driver assist systems, like automated emergency braking, lane keep assist, and pedestrian collision warning systems, just to name a few. These technologies have the potential to significantly reduce traffic accidents and congestion, and even open up access to mobility for those with limitations from age or disability. And next, please. And connectivity and automation are each made more powerful by the move towards services like rideshare or car share. Think about it. If ubiquitous connectivity means that you can always have access to the exact vehicle you need at the exact time you need it for only as long as you need it, you may be interested in something different from the traditional concept of vehicle ownership. And I don't need to explain how significant that would be to the auto industry. Next, please. And finally, E, electrification, and perhaps the most appropriate for today's topic, because we as a society must reduce emissions from personal transportation. There's no question that we need to move toward electrification. Rather, the conversation is how to transition and how fast will this transition occur. Now at Toyota, when we say electrification, we're referring to anything that runs on electrons. This includes battery electric vehicles, conventional hybrids, plug-in hybrids, and even hydrogen fuel cell electric vehicles. All of these alternatives will help in the pursuit of lower carbon emissions. Now, too often electrification has been defined exclusively as battery electric vehicles, or BEVs for short. We agree that BEVs are an important part of the answer, but they're not the only answer. The narrow focus on BEVs as the only solution stems from the view that they must be the most carbon friendly since they burn no gasoline. And it's true if you compare an average hybrid, plug-in hybrid, BEV, and fuel cell, you'll find that BEVs and fuel cells are the lowest emitting in many cases, but not all cases. In fact, recent data shows that plug-in hybrids can achieve nearly the same or better greenhouse gas reductions than BEVs, depending on your daily driving patterns, the carbon in the electric grid, the carbon resulting from battery production, and other factors. This is why we believe that offering our customers a full portfolio of electrified solutions is important so that they can identify the one that's right for them. You know, Toyota has been in the electrified vehicle business for a long time. We introduced a fully electric RAV4 in the US in 1997 and a second generation in 2012. And starting with the Prius launch in 1997, we've sold 17 million hybrids globally and over 4 million right here in the US, the more than the rest of the industry combined. Now, the reason I share this is because through this experience, we've learned that transitioning to a new technology takes time. You know, we're proud of having sold more than 4 million hybrids here in the US, but it took us 20 years to get here. Achieving significant BEV penetration may pose an even greater challenge given the cost of batteries, the need for national infrastructure, long recharging times, limited driving range, and the need for consumer behavioral change. So looking ahead, while we all strive for a carbon-free transportation system, we have much more work to do. Next slide, please. So in closing, let me reiterate that the four case megatrends will and are changing our industry, and all of us need to be ready to adapt. This is a major change for our company, but for Toyota, major change is nothing new. 80 years ago, we didn't even make cars. We made looms for weaving textiles. But just like today, technology was a driving change in society, and Kiichiro Toyota had the foresight to see the potential of the automobile. And Toyota changed from an automotive company to an automotive company to meet the opportunity. Today, Kiichiro Toyota's grandson, Akio Toyoda, leads Toyota. And just like 80 years ago, the world is going through a new technology revolution, and once again, we'll transition to a mobility company to meet these challenges. So thank you for your kind attention, and I'd like to hand things back to Richard. Thank you.
Jeff, thank you very much. Our closing presentation is by Rayford Smith from Google, and after that, we'll have our panel Q&A.
All right, thank you very much, and appreciate the opportunity to speak to everyone today. And so if you don't mind, let's go to the first slide. Next slide, please. So one of the questions people ask a lot is, why does Google use a lot of energy? And really that's both a simple answer and a little bit complex one. And on the next slide, the first part of that answer is we have a lot of products with over 1 billion users, and behind each one of those products is a significant amount of computing resources which consume energy. Things like Gmail or Maps or Mail, we use these every day. And there's a data center behind each one of those. Next slide. To give you a sense about that, though, we also work behind the scenes to have reliable electric supplies to all of those data centers. And our most important priority is to make sure they are up and running. After all, if we don't have a data center operating, then we can't provide the services our customers want. And to put this in relative context for folks, last year, in 2019, Google used as much energy as the state of Hawaii, Washington, D.C., San Francisco, right? There's a considerable amount of energy that we consume. That being said, one question that always inevitably comes up about data centers and energy consumption is how much do we consume relative to what we're displacing? And actually, in that sense, we're actually using less energy than ever before. And it's because of the economies of scale, right? Instead of lots of little data centers and computers, we're able to consolidate them into massive data centers and get efficiencies out of that. But we have an enormous footprint here in terms of energy consumption. So next slide. With that, we drive our energy consumption really with 3 key things in mind. Resiliency, as I mentioned, we need to have a reliable supply to our data centers, low cost, and of course, carbon-free. And while Google is here talking to you all today, I think we all represent probably the same objectives for most large companies today, which is We all want these three attributes in one form or another. Next slide. So when we think about efficiency and how do we do that, our data centers, as I mentioned, they're actually twice as efficient as a typical data center. We do that through a combination of machine learning, innovative use of technology, and ultimately being able to do better at predicting things like what are market prices, what our carbon content look like, and then how should we operate our data centers to understand and operate in those complex energy markets. Next slide. And so while we're doing that, one of the things we've tried to do is always be an innovator in the space, and specifically around how clean is our energy. We have been carbon neutral since 2007, and we've been 100% renewable on a global annualized basis since 2017. However, being 100% renewable isn't good enough. We realize that there's even more to do. So next slide. So if we think about our actual footprint all over the globe, what this slide is showing is basically the carbon content of our data centers. You can see in the ones that are greener, we effectively have far more carbon-free energy content than in ones that are grayer. More gray equals more carbon, less gray, more green means more clean energy. And when we think about this, while we match this on an annualized basis, when you start to actually look at each data center, you can see that our operations are not consistent all over the world. Similarly, where renewable energy is not consistent with where data centers are. And so we have to find a way to match that. And so our newest initiative is around 24/7 carbon-free energy. Basically, we want carbon-free energy for every day, every hour, at every data center. And this is a monumental task that really involves transformation around 4 key areas. Data and analytics. How do we create the insights to figure out how to get where we want to go? Regulatory and policy. How do we look at markets and market rules and regulations so that they are conducive to these sorts of activities? Technology, meaning the hardware, the physical infrastructure that we use to both receive energy and utilize it day to day in our assets. And then fourth are the commercial contracts and structures that we use to pay for all of this. And so we're looking to innovate across all 4 areas, but ultimately, when we think about it, we're looking at this problem here, which is we have data centers in very diverse locations, and their energy consumption and the carbon content behind it varies significantly, and we're trying to match that everywhere. So next slide, please. So one of the ways we do this is using DeepMind. And DeepMind, effectively, we use a neural network to predict not just wind power, our output of our assets, but also forward market pricing and weather. And then we use that effectively to dispatch the assets to get additional value out of them. And as such, not only do we increase the value, the monetary value of the asset, but we also better understand our carbon-free energy content and how to manage that more effectively. On the next slide, we also, in addition to doing that, we also have the first ever battery backup system for the generator replacement at a hyperscale data center. We're doing that in Europe. We're using it not just to replace the on-site generation, but also to think about how to add additional flexibility so that our resources and our physical assets can now provide grid services. This is, as it is with many other customers, they're also looking for, and the transformation is really heading towards transactive energy between consumers and the grid itself. And what happens is that as those customers gain these capabilities, we believe, we, Google, will also be part of that transactive process, which is we'll be using our assets to provide additional value to the grid and add to resiliency. And at the same time, we'll also receive the benefit of others doing the same thing. Next slide. And so when we think about this, it requires another different approach to even how we think about renewable energy credits. So today, the way the REC works is effectively it's not time bound. You just buy a REC for a particular period of time, a month, and when that energy is produced, you receive a REC for it. However, when we think about renewable energy, one of its key attributes is that it's intermittent, and it has different value. Energy markets have different values based on different times of the day. And so a REC kind of papers over the problem. And so what we're looking at are now these time-based energy attribute certificates that allow us to not only acquire renewable energy credits or their equivalent at the time when we need them, but it also sends the proper pricing signal back to the market to develop resources in those hours when those resources are needed most. And so this is the kind of one of the commercial innovations that we're looking at. And then on the next slide. But being able to manage generation resources, being able to have new commercial products isn't enough. One of the things that we're most proud of that we're doing is being able to do intelligent load shifting. And what that means is that we can actually shift demand temporally in this example, but also geographically, so that we can take advantage of different market conditions. So for example, if you want to optimize around carbon computing, we can shift our carbon content in the grid. We can shift that to a place where there's greener energy. And then if the wind picks up or we have cleaner energy at a later hour, we can shift it back. This allows us much more flexibility. It also allows us to add resiliency to our data center fleet so that we always have that uptime so that customers are getting the energy, getting the computing capability that they need. It also allows us to optimize on things like water usage and other areas. And so it gives us a multi-dimensional optimization about how to manage load. You compare that with also the things that we were describing earlier, like our ability to predict when renewable resources or when carbon-free energy resources will be producing. And you can see that we are trying to look at both sides of the equation, what's happening in the market, what's happening with our assets, and how to co-optimize those together to achieve the sustainable outcome that I think we're all looking for. So with that, I look forward to the questions and definitely look forward to explaining more about not only what Google is doing, but also hearing from the other panelists and what their companies are doing in this exciting space. So thank you.
Great. Rayford, thank you very much. I presume all of you are unmuted. Is that our format now? I see Ajay is muted. Jeff is unmuted. There's Ajay unmuted. Okay.
Yeah.
We have got between now and, I want to leave about 15 minutes for Q&A from the floor. So let's say we've got about 40 minutes, round numbers, to discuss questions as a panel. And really what I want to focus on initially is not the technology so much as although that seems to be the first place, every corporate presentation wants to go. I want to talk about the hows and the corporate decision-making process that's going to get us to for example, ambitious targets like net zero by 2050. So I characterize the energy future as highly uncertain. I don't know if you all believe that, agree with that. I think there are some guidelines to that, but as you're looking at this uncertain future, there are really some significant impacts that could come as a result of one scenario coming to pass versus another scenario coming to pass. So really what I would like to know is how are your corporations actually handling this sort of decision-making process? How are you deciding where to place your bets? I mean, we know that some of these bets are going to be higher risk and not profitable initially. How are you doing all of that so that you can remain a going concern and yet prepare for the future? So I'll just kind of go Ajay to Jeff to Rayford. I'd like to hear your perspectives. Ajay.
Great. No, thanks, Richard. No, I think that's a great question about how do you make decisions on capital allocation, given the uncertainties that we are dealing with. So the way we think about this is we are making kind of a fundamental kind of internal shift in kind of what kind of company are we going to emerge into as the energy transition unfolds. And we think of it in terms of three discrete pillars. The first one is that our existing conventional business is absolutely going to be around for decades to come. This is not just a magic switch that can be turned on or off. We're going to continue to provide the world the energy that it needs, which is going to continue to include a number of our existing, upstream and integrated gas assets. That, in fact, our core business is the one that actually funds the energy transition, so to speak. Yeah? So that's very much the fundamental bedrock of that, while recognizing that we do see the peak, if it's not already come, is pretty much there, but it's going to be a peak in terms of a demand side of the equation. So we will see a year-on-year reduction in investment and capital allocation in some of those upstream businesses, in the future, and a more refocus on a few key areas where we believe we can get the most value. The second part is the shift towards the low carbon fuels. So that's the transition business pillar. And we continue to see year on year an increase in the gas portion of our portfolio. So, and that's kind of another arena where we do see gas replacing coal in a lot of parts of the world. And again, it's certainly a cleaner burning fuel. So we do. I know there's a lot of conversation around, is this really truly a transition, fuel or not? We truly believe that gas has an important role to play in this mix, and so we see that as kind of a transitional pillar with our LNG business and our integrated gas business. And the third piece is a year-on-year increase in the investment in the growth pillar, which is truly where this new energies piece comes. So currently, at the present time, we are already allocating between $2 to $4 billion a year of our capital in this space. That is something that we see is going to continue to increase in a dramatic fashion as we start building a fourth vertical in power. So we have had oil, gas, chemicals, for decades. Power is going to become that fourth vertical, but it can only happen in conjunction with each of these three pillars working in close proximity to each other. There's no one single leap that we're going to make. It's going to be happening and unfolding, but with a true sense of purpose towards where we want to go in the future.
Okay, great. Thank you, Jeff.
Yeah, well, I think it really starts at the top, trying to create the vision and direction for the company. And this is going to sound a little bit corny, but our CEO, global CEO, Akio Toyoda, his name is on our vehicle, he created the vision of making customers happy, and actually went as far as to say, make them smile. And that's kind of Toyota's goal. And so as we look at all of these issues, of course, there's a lot of issues that have to be managed, right? We're talking now about sustainable development goals and reducing carbon neutrality. There's social justice goals. We now have a policy with USMCA and trade, and all these things have to be managed, but they shouldn't distract us from our main mission again, which is taking care of the customer, which is why we're trying to make investments through R&D, through partnerships in new companies, partnerships with new companies, in solutions where we feel we can add value downstream to the customer. So in other words, looking for some of their pain points. But to really standardize this vision, our executive team created what we call the Toyota 2050 Environmental Challenge, which lays out our aspirations and our targets for CO2 emissions, for conserving water, for reducing waste, for protecting biodiversity. And once we have that vision, then the business units start to put together the action plans about how to deploy and where to deploy and how to do it in a smart manner. So, again, it really starts at the top. A lot of action plans. It's really frequently discussed. As you know, things change so quickly that you have to refresh your plans several times a year. But again, hopefully it's just a refreshing and a tweaking, and it's not a major overhaul.
Okay, thanks. Rayford.
Yeah, so for me, I think it begins with the concept of, and I'll paraphrase the great hockey player Wayne Gretzky, who said, I don't skate to where the puck is, I skate to where the puck will be. And I think that's probably the first fundamental pillar, whether it's of leadership or of a company, is trying to not just delight the customer, but know where the customer wants to be. I think that once you have that in mind, I think the principle behind it is having good, strong, solid ways to create insights as to what does the customer want and what is the best way for me to allocate capital and to de-risk my business and to move to that outcome. And that to me speaks to a fundamental associated with data and analytics. And not just because I work at Google. I mean, I spent 30 years in energy prior to coming to Google. You really want to have a good understanding of what's the priority, why do I want to go there, what's it going to cost me, what's the benefit that I'm going to generate, what's the risk and return of it. I think if that's the kind of the motivating factor behind trying to make decisions, I think then once you're kind of going in that direction, whether it's to delight your customers, to provide those services, to reduce your costs, to improve efficiencies, those are all suitable outcomes relative to whatever we're trying to do. But it does very much begin with having the desire to be where the customer wants you to be and understanding that, and then using analytics, insights, et cetera, to drive you in that direction.
Okay, very, very briefly then, Rayford, where does the customer want to be? What's the number one item?
Well, it's interesting because we're all talking about energy and energy transformation here. I can tell you that in my past in working for utilities, we always had this thought that customers really don't understand the trade-off between, the cost of doing this sort of thing and the benefit that they might get from it. But at the top of the presentation, I thought you summarized it well, which is if that really is how we approach the problem, we get those forecasts that always miss, right? And say that adoption looks ridiculous, very lower than what it is today. When I think about what customers want, they want it faster, better, cheaper. They want it cleaner. Cleaner is as much a priority as anything else. Yeah. That doesn't mean, though, that we have to blow up and start over and do things completely different. It does mean that how we get to the outcome the customer wants, which is really as much around how we get there and clean capabilities as it does about, whatever the end product is that the consumer wants. But, think about automotive transformation. People don't buy electric vehicles just for the cleanliness. They also buy it for the experience, right? Those vehicles operate more efficiently. They have better torque. Same thing for where we are in analytics and in Google. Like, people don't just buy it because it's clean. They buy it because it's a better product. And that ultimately is what this is an underlying attribute too, which is better products for consumers.
Yeah. So kind of along the lines of, better, faster, cheaper, and cleaner. Now, as we consider the imperatives that maybe a shareholder and other stakeholders like society at large want, Ajay, when I look at the cleaner portion of your presentation, part of it, for example, one slide you showed, which is truly eye-opening, is a slide showing the % increase in electrification.
Yes.
As I look at the trend, which is fairly well behaved up to almost the present, and then I look to the future, they are wildly divergent.
Yes.
Is that even remotely a basis for Shell to say, yeah, this is our planning basis?
No, I think that's a great question, because there's an aspired kind of target that we have, that this is kind of how the world would need to evolve to in order to get to these net zero targets, and then there's the reality of what is the true pace and uptake. Depending upon which part of the world you're operating in, there's cause for more optimism, or less. So even to your prior question, around the customer, we think about this in terms of different geographies, because certain geographies in the world are more kind of willing and ready to make that next step. But the part that's still missing is around the who pays, and I think this is kind of an important part of the conversation today also, because magically this infrastructure is not just going to happen. That is going to be required for making this electrification. Even when I heard Rayford's fantastic presentation on the data centers and the energy demand, one of the things that goes into my head also is that a lot of these data centers are in remote locations. So even if you wanted to kind of have complete clean electricity coming into these, what is the infrastructure to even get it there, and what are the evacuation pathways? How are we going to kind of put that sort of investment into place? But I do believe, Richard, that there's plenty, of course, to be optimistic about it. Certainly in the Western world, I do believe that the trends are in place, and especially now with governments getting their acts together and saying, yes, we are willing to make those type of investments that'll be necessary to work with private enterprise, along with the right kind of policy incentives. I do believe that it can happen. Whether the pace will be the pace at which we would like to see is to be determined, and of course we would have to kind of modify the pace at which we grow our own new energies business and positions as a consequence of that.
Yeah, I mean, interestingly, as you look at that pace of electrification, really what we're interested in is the pace of, let's call it, clean electrification. And what we know is that in many parts of the world, the parts where energy demand is growing fastest and where CO2 emissions are growing fastest, and where this is going to be a huge problem, that's a challenge. And
absolutely.
And so as I look at these, and I look at the measures one might take to address CO2 emissions related, for example, to power generation and electrification. Then I look at the costs related to that, and you mentioned CCS, for example. Making that viable, financially viable, let's say commercially viable, to where an investor might be interested in, is a challenge. So I'm trying to explore the not the impossibility certainly, but the great difficulty. And I've heard words like daunting, unprecedented. I mean, words in in this Energy Week that suggests this is incredibly tough thing to do. And so how realistically, and of course I'm assuming very realistically, are you looking at the bottom line? And I want Jeff to come into this discussion, and Rayford as well.
Yeah, Jeff, would you like to go?
Yeah. So yeah, that's exactly the point, and I tried to share that in my remarks earlier, but I don't think there's any doubt we need to get to an electrification future. It's what is the best method to get there, and how quickly will it happen? Yeah. Today battery electric vehicles are still less than 2% of the market. If you look at the customer, trying to understand and anticipate what they want, they're affluent, usually over $120,000 earned per year. They have multiple cars in the household. They're college educated. And, we can go on and on and on, but that doesn't, the majority of the public doesn't meet those criteria. And so you have to offer other solutions. The average age of a vehicle on the road is over 11 years. And so the best way we can start reducing the carbon footprint is to start replacing out some of those older vehicles. Right. And trying to upcharge them to a $70,000 battery electric vehicle may not stimulate them to decide to turn in their older truck or their older sedan. And so this is where, again, I'm not saying we shouldn't encourage by policy. I think there's a role for policy, but I think we also have to balance that with the consumer needs and the consumer desire, and find a middle ground where policy can support us in this path, and not direct or dictate like they're trying to do in China and Europe.
Yeah. Okay. Rayford.
Yeah, so today is the anniversary of the printing press, right? And when that came out, we were able to publish a lot more things, and then typewriters were invented. To me, like I look at these kind of technological innovations, they don't remove the underlying need for the ability to communicate. Like in the case of the printing press or the typewriter, we still need to, in the use of energy, move, if it's for a car, or compute or do something, right? There's always this underlying need to do it, and that's not changing. It's really what's changing here is the underlying mechanism to do it. And the real question is what innovation, what capability, at what cost point will really stimulate that. I think Jeff's points are right on, as were Ajay's. I definitely think we're still going to want to do these things, and it's not a one size fits all, and certainly not a one cost fits all. And so there's going to have to be a basket of options that are necessary to ultimately create these outcomes. But as I mentioned in my own talk, I really think it's innovation in 4 areas. It's data and analytics, but it's also just as much the hardware, the regulatory policy, and the commercial structures. Like we need not just different price points, but we need regulations that allow for types of vehicles or capabilities to get to the energy outcome we want. We need data and analytics to help us drive and understand what those insights are. And we need the commercial structures to follow suit. Like all of that has to come to play. I think about how many cars were sold when you had to finance it or just pay up front versus financing it versus leasing it. Each one of those was a commercial innovation that improved that. I'm thinking this sort of energy transformation needs all of those innovations in all of those areas to come about. And I think it will beat all of our expectations, but I have no idea how that will actually play out.
This is kind of the I think the challenge public at large has in listening to what people plan to do is that the future is really quite aspirational, and so you're wondering, are these aspirations being reflected in real corporate cultural change, or are they really kind of not? I look at right now. I look at the commitment of different countries to the RTS scenario, basically the scenario where companies outline the measures by which, or governments outline the measures by which they would meet the Paris Climate Accord objectives. Those are way short of the 2-degree criterion, and the vast majority of countries are not delivering on that. Europe as a continent is really about the only area that is. So this to me is the challenge. You all are speaking to it, which is melding together the natural objectives of a company who has shareholders to respond to, and the broader issue of society, which is climate change. And of course, there are other broad issues like alleviating poverty in the developing world, and the list goes on and on. As you look at this, and maybe Rayford, your perspective is really less central to the point of my question, but when I look at Shell and I look at Toyota, two very tried and tested, established, successful companies, looking at a potentially significantly different future. You've gotten to where you are because of your corporate culture and because of your sense of identity and what you've done very well. What as you look to the changes that are going to happen at Shell, how do you see the corporate cultural change evolving, and your strengths? What do you see as your strengths, and also, if you would, speak candidly to maybe the weaknesses that you think need to be remedied. And how about Jeff? You start first, and I'll go to Ajay and then Rayford.
Yeah, well, thank you for the question. I think, obviously, Toyota has a very long history, over 80 years, and we've developed a very, I would say, deep culture, right? And it's rooted in something we call the Toyota Way and the Toyota Production System, which I think, a lot of you have read and heard about. And I think it's really important as we transition to a mobility company that we don't throw the baby out with the bathwater, right? You want to embrace the strengths that got you where you are today, which, in our opinion, our quality and dependability and reliability, we need to keep that as our core DNA. But as we transition to a mobility company, we have to think differently. We have to move differently. What's got us to where we are today in today's world isn't going to be enough to sustain us. And so our executive team is encouraging our team to think differently. And to Rayford's point, software, data analytics, we're seeing tremendous growth in this area for multiple reasons. As I mentioned, all the data that's coming off the vehicle. For those of you that design a car, in many cases, we anticipate how the customer will use something, and then we'll create design and performance specifications around that. And if they use it in a different manner and something goes wrong, then we have to go back to the design and we add all these reflections and documents and procedures to make sure it doesn't happen again. But now with the data coming from the vehicle, we don't have to guess. We know how the customer is using their vehicle, and we can design, and so we can right size, if you will, based on the customer demand and expectation. And if there's a quality issue, we don't have to wait until X amount of customers have the issue and complain and then report it back through our quality organizations. We know instantly, and so we can act much more quickly. So that's on the quality side. The other side too is data analytics. This will change the way we develop cars. I would say previously we were a hardware first company. We developed the hardware and then we input the software to the component. And what's happened is, unlike a cell phone or a laptop, very difficult to upgrade because in many cases the hardware wouldn't support it. But now we're totally changing the architecture. We call it software first. If you can design the software architecture and you know what it wants to do and what capabilities it should have moving forward, then you can design the hardware around that. So it's a totally different way of thinking for Toyota, but this is how we have to change the way that we develop future vehicles. And things such as over-the-air updates. Right now a few vehicles have that, but that's going to be standard on everything. And so it's opening up new challenges, but certainly new opportunities for us moving forward. Great.
Hey, Ajay, of course, you and I come from similar backgrounds, at least professionally, and
yes,
I worked for a company similar to yours. So I'm very curious to hear how you would kind of promote the existing Shell culture, and then talk about areas where you think it needs to be, maybe redirected to a degree to meet the objectives of the future.
Yeah, no, thanks for that question. It's a great question because as we are preparing for this, world to come, we do need to reflect upon, what is it that we need to change. So the one thing that we take tremendous amount of pride in inside the company is that it's got a deep roots in technology and in engineering prowess. And so our DNA is geared towards kind of doing big things and doing them well, and kind of being an innovator and being kind of the play opener in many parts of the world, and doing new things. And that culture, I think, lends itself very well to this energy transition. The part that's different here is the pace at which innovations are happening, whether it be in the digitalization space that Jeff and Rayford were talking about. I think that's the part that I think we need to embrace a lot more, a lot better inside the company, because you could very quickly be left behind if you don't start, taking that on board. Digitalization is something that everybody talks about, but but how do you truly embed digitalization in everything that's? I believe in the oil and gas sector, we are actually slower than our other industry sectors in actually taking that on board and truly unlocking the value of what that can do. The other part that I think, and we are beginning to talk a lot about this internally inside Shell, is thinking in terms of putting the customer at the center of everything that we do. That's again a shift in kind of a mindset, because the customer is coming in with a very unique set of asks and priorities, and the customer's priorities might be very different from what you think that you have traditionally kind of provided to them, and the customers are different in different parts of the world. Our European customers, for example, when we even talk about green projects, a European customer's willingness to pay for green electricity might be very different from a customer that we might be working with in Asia or a customer that we might be working in Texas or in California. How do we kind of respond to these different type of customer demands and asks? Jeff talked about kind of the future of transportation. How is that going to impact some of the products that we make and some of the products that we sell? So how do we kind of factor in changes in consumer consumption patterns? Is it going to be just a like for like replacement? Because we think it's not just about a supply side of the equation, but what is the demand of that future going to look like? It will be very much dictated again by the customer. So when we think in terms of kind of transformations internally, going from a mindset where it's been kind of more centrally, decision making has been more centralized, to having much clearer ears on the ground, globally dispersed, understanding unique local cultures and local demands, but starting with the customer first and then figuring out how does that get incorporated into the business decisions we make. That's a big significant shift inside the company, Richard.
Yeah, I'd say it's very interesting, your response. And frankly, I would have probably given a similar response as an ExxonMobil executive. Mm-hmm. But I will offer that a perspective that perhaps the biggest challenge for companies like our own is the interface with society. I mean, we are so good at solving technology problems. And I think that's true for Toyota, and it's certainly true for Google. I mean, that's kind of the default response. But how good are we at doing what you kind of described indirectly, which is listening to what society is saying?
Absolutely. Absolutely, yeah. And again, whether it be access to energy questions, because it's great to talk about kind of what kind of products and services we might be interested in selling in the developed world, but recognizing also the billion customers around the world that don't have access to basic energy. So what kind of role do large corporations like ours play in that? So towards that end also, we have set an ambition of how we're going to get electricity to 100 million people by the end of the decade, and the solutions that you offer there might be very, very different from the solutions you might develop in the Netherlands or in other parts of Europe or the US. So absolutely.
Yeah. For sure. Rayford, some quick comments on that general topic.
Yeah, I mean, what comes to mind is the innovator's dilemma from Clayton.
Sure.
I mean, this is all about companies are forever in all industries and in all areas. They're always being disrupted by new technology, new marketplaces, new things. And how they react to that is really the defining feature of their survival and growth or their eventual demise. And to me, Clayton's book here really kind of sums up the rationale for being conservative and protecting one's current market and capabilities, and what makes it so hard for those companies to truly innovate out of that box. But it can be done, and it's been done. There are several good examples of it. I think this is the same thing that's playing out here in energy, which is how do we think about transformation and change, realizing that we have a good business as it stands today. What do we need to be doing to not just listen to our customers, but ultimately get to where they're taking us? And it does start with putting them in the center of the conversation, but it also means having a hard look inward and saying, like, what do I need to keep doing and what should I change?
Yeah. On the technology side, coming back to the area of where the biggest impact could be made, and I'm offering that I think it could be in the developing economies of the world rather than the OECD. How do you see addressing some of those challenges technologically relative to the way you might address problems in the United States or Europe? What are the differences in solutions that you might apply there relative to here? Jeff, just quickly, please.
Yeah, it's another very good question. Certainly there are different solutions. And I think what we're trying to do, and I think one of the key words I'll throw out there is partnerships.
Yeah.
We recognize we can't do everything alone. And furthermore, because of the speed and the pace of what innovation is happening, you have to play small bets. And you have to put feelers out there, and actually with several of the members on this panel, we've had partnerships to deal with some of these issues. Hydrogen infrastructure, working with Shell to deploy stations. We can't do that on our own. And as an automaker, we hesitate to actually involve in infrastructure, but we know the importance. We're working on new business models with Amazon Web Services and Microsoft, where we're looking at how vehicles connect to the grid. When do they charge? We started a subscription last month that a customer can actually charge their plug-in, and we'll bill them for renewable energy that we're providing. And so there's all these new kind of business models that we're exploring. And what we're trying to do is, again, for each market, each location, try and place these small bets to see what works, to see what customers want. If you're going to fail fast, learn and move on. So that's one means that we're doing, and I think partnerships, that's a really key activity, for all of us.
Yeah. Hey guys, I've got like 2 pages of questions, and I'm going to get to about 25% of them. But I do want to finish before we go to audience Q&A on this one. And really, it's been prompted a bit by Rayford. It's been echoed by Jeff and Ajay, and that is the whole notion of the Internet things and data analytics. So sensors and the ability to gather vast amounts of data, analyze and respond in ways that we could never do before. This to me is fascinating, exciting, but it introduces a whole nother corporate risk that I have to believe that Toyota and Shell are worrying about a lot, which is cybersecurity. So I'm imagining a world where Ajay is sitting at his desk and he's got Alexa up, or maybe Google Assistant or Siri, and he says, Siri, where should I put my next volume of CO2 from this plant? And ultimately, that whole integrated system that makes it so powerful is exposed to risk. So Rayford quickly, and then Ajay and Jeff.
Yeah, I mean, when I was in the energy industry, I used to somewhat pityingly laugh about our cybersecurity folks because they were always the last one consulting, right? Well, look, the business would say, I want to go do X, and then I got to go talk with those guys over there, right? And that, I think, was part of the fundamental problem, right? Is that security was always seen as a barrier, not as a feature. But the problem or the opportunity that comes here with this digital transformation is that security is a feature, and frankly, a very, very important feature. And when I think about energy infrastructure, energy management, risk management, all of these things, like this is increasingly becoming, if not the #1 topic in the conversation, in the top 3 for sure. Yeah. And we need to start thinking about not just how do we do things more sustainably, but how do we do things more securely? And it has to be embedded from the very beginning in everything that we do.
Yep, thanks. Jeff, real quick.
Yes, we think this is a critical area as well. The easiest way to lose your reputation or damage it is to have some type of customer leak or issue. So not just on the cyber front, but the consumer privacy front as well, making sure consumers' data. So we have a chief cyber officer, and we're actively discussing and dealing with these issues, but it's a challenge. It's an emerging area, it's an emerging risk, and it's something, again, that we're going to have to learn from. But we're doing everything in our possibles within our company to make sure that we forecast, foresee, and plug any gaps and holes that we have.
Great, thanks. Ajay,
Yeah.
very
Yeah, just very quickly, I think you've hit the nail on the head there, because it's cybersecurity, not just at a macro level, but also at a consumer level, day to day. I mean, when we think about kind of the number of customers we deal with on a daily basis, with the 44,000 retail stations we have, as we transform to a kind of electrified world, even the act of the protocol of charging, your EV vehicle that you bring up, involves all kinds of questions around data and data security and data privacy and the like. And how do you ensure that you're doing that the right way and ensuring the privacy of the customer and not compromising on that? So there's multiple levels of that, and we can kind of go on multiple tangents on that, on how we would actually do the surveillance and ensure that that is kept secure. But it's a huge area of interest and focus.
the great opportunity, maybe the great enabler, and certainly a risk. I want 5 minutes, and I want kind of a short answer from each of you to a relatively simple question. You're at a major university looking to hire students for your enterprise. What are you looking for? So start with Ajay.
Oh, looking for massive amounts of curiosity and optimism. That this is not a problem that is intractable, but I truly believe that the career that the students graduating right now is going to be perhaps the most exciting that they're ever going to have. To have a front row seat in the energy transition, my goodness, how much better than that does it get? So curiosity and interest in actually diving in and regardless of what discipline you're coming from, there's a need for you in this brave new world.
You're saying that, of course, you're saying that in the face of massive layoffs in the oil and gas industry, and really
absolutely
very modest hiring by the oil and gas industry. So what reassuring things can you say to people contemplating careers on that side of the energy business?
That's a great question. And even internally within our own company, we are going through a difficult period, with that, especially with the changes in our portfolio. But I do honestly believe that some of the skills and capabilities that have allowed us to be successful for the past 100 years are some of those same skills which are going to be required, in the future. So I don't think there's a fundamental shift. Yes, data sciences and robotics and all of this will probably play a much bigger role in the future, and perhaps we will be hiring more people with those types of skills than traditional, geologists and geophysicists. But in the grand scheme of things, we are still going to need those same skills and capabilities as we talk about things like energy storage and CCS and other projects like that at scale.
Yeah. Great, thanks. Jeff, quickly, your view.
Yeah, I think on the hard side, I agree. I think we want innovators, we want problem solvers, people that aren't afraid to challenge the status quo. Certainly data analytics, like I said, is really emerging across all facets of the organization. So if you have some of those tools and background, it's great. But I'd also like to emphasize the soft side, being able to communicate. Being able to work as a team. These are, quite honestly speaking, gaps that we're currently discovering and having to reteach when companies or when employees enter our company. And so, if we can do things early on, whether it's through internships or mentoring programs to help with those, I think it would be very helpful.
Thanks. Rayford.
Yeah, and I'll echo those remarks by saying Google looks for 4 attributes in its interviewees. The first one is they look for role-related knowledge. The second is they look for general cognitive ability. But when you start to shift from that, you go from those are the hard skills, and then to, as Jeff points, the soft skills, which are leadership, which is the third one, and the fourth one is what we call Googliness, which is really the ability to communicate, the ability to work together in a team. Right? These are not to be, put aside as a minor thing. These are really important. If a quarter of your grade is going to be how well you work with others, you should probably focus on that. You can work in teams as much as possible. And so these are the things we look for anyone, whether entry-level jobs or senior management, to demonstrate one way or the other. I think these are all going to be important attributes in any role, whether you're working at a Shell, a Toyota, or a Google, or anywhere else. One way or the other, you need to demonstrate those things.
Yeah, agreed. Okay, I'm going to switch over to audience Q&A, and our curator here, Dave Tuttle, is putting up questions which I hope he'll kind of put in order of general interest. The first of those is really probably directed to Ajay more than anybody else. But what is required to have CCS or CCUS, so carbon capture and sequestration, or carbon capture utilization sequestration, and direct air capture be economically viable and viable at scale? Some place we're not yet today, and I'd be interested in your response to that.
Sure. So just very quickly, so you can get more questions in, is the first one is on the CCS side. I think it's about deployment. We just have to do a lot more of it. We already know how to do it. We one of our flagship projects in Canada called Quest, we have been sequestering 1 million tons a year of of CO2. We need to just kind of replicate this. And so in order to do that, one of the things the missing link there, as I said, is public-private incentives. So with 45Q and all, which have been in place, some of the first generation of that has been quite complicated, and how you can actually go from policy to implementation. So simplification of some of the policy and legislation around that would dramatically accelerate CCS. On the CCUS part, on the utilization part, there are lots of great ideas. Some of the technical readiness will require a little bit more time to develop to really convert that carbon to products. And there's a massive amount of work going on in both in industry and academia on converting carbon to value. And so we will be hearing a lot more about end users of once that CO2 has been captured, including doing things like making synthetic aviation fuels. That's something that we have just recently made a large-scale demo of that, of how do you make a synthetic aviation fuel with CO2 that is captured either from a point source or from the air, combine it with low-cost hydrogen, and then make a synthetic fuel at demand. And the last one on the direct air capture, I'm a little bit more bullish about the promise of this technology. But I would put in a little bit more of a caveat around the timing. I think when some of the things that we hear about in terms of this is ready to go, and it's going to come down to a cost point of less than $100 per ton, I think is a little bit ahead of facts. So, but I do believe in the technology. I think whether it be the liquid sorbent system or the solid sorbent system, there's plenty of potential and there's plenty of upside too. There's lots of questions around, is it ever going to be going to make thermodynamic sense to do it or not? But there are lots of upsides of direct air capture because you can put it where you want, and at the end of the day, direct air capture and technologies like that, the so-called negative emission technologies, are going to be necessary, to get to a 1.5 or 2 degree C world. It's not an option. It's going to be required, even at a higher, cost point. Yeah. But I truly do believe that within a decade, we will start getting towards that $150-ish, $150-$200 sort of price point for direct air capture. And perhaps in the decade after that, we can truly drive it down to a further lower cost point with further uptake of that technology.
Those numbers seem more reasonable. My recollection of your slide, though, I was surprised how low your cost of carbon was on that chart. I didn't think it got to those numbers till 2050, and that seemed like a very long time for it to get to a place where most people think it needs to be today.
Yeah, we'd love to have that come in earlier, but this is kind of just our internal thinking about based upon kind of the history of how we see this unfolding. Because again, getting a ubiquitous carbon price, of course, is not that easy. Given some of the history we have had with the emissions trading schemes and the like in the past. So we would like to get it to a robust level where it truly starts driving technology uptake. But that's kind of how we see the story unfolding, Richard.
Yeah. So maybe best directed to Jeff here. Will transportation truly be entirely electrified, and maybe not 100%, but largely electrified? What are the key advancements required to make biofuels viable at scale and at competitive cost?
Yeah, well, yes, I think electrification is certainly going to be the future. And as we've talked about many times, it's just going to be how long. Yeah. Again, you're going to see a very slow transition. As I mentioned, it took Toyota 20 years to get up to 4 million units of hybrid sales in total. By 2025, there's going to be probably 150 battery electric vehicles on the road, all competing for 500, 6,000 unit market share, which means, it's going to be tough for some of these vehicles to survive with such low volumes, 40,000, 50,000 units a model. It's going to be very hard to be profitable. So, we're going to need, I think, government incentives to probably support during this transition. I know the Biden administration is now looking at their infrastructure bill, about $100 billion for a cash to clunkers type program. If you look at a $6,500 to $8,000 incentive, that would be enough to maybe incentivize about 1.2 million vehicles. So still about 8% of the total market. So it's going to take a ways to get there, most certainly.
Yeah.
And then on the biofuels discussion, that's something that we continue to look at as an automotive company. Certainly vehicles today are capable of supporting biofuels, but the issue has always been just getting it on a cost basis, getting it to where it needs to be. There's also issues, food versus fuel and cellulosic versus non-cellulosic. So always a lot of challenges there. But again, I think most people are now putting their research dollars into electrification versus bio.
Yeah, okay, thanks. So Rayford, a rather general question, but I'd like you to address this. What would be the best way the public sector could work with private industry to facilitate the energy transition?
Yeah, I
think this is twofold. One is the role of the private, the role of the public and private sectors, and then how could they work best together?
Yeah, I think first, private and public partnerships, partnerships in general, are what's necessary to get to the outcomes that we're looking for. No one company or country even can do all of this alone. That being said, the way I think about these is that there are two different strategies that we could go implement as in this partnerships. Those that are mitigative, meaning we're just going to mitigate the bad things about what we're doing, or transformative, meaning I'm going to focus on the good aspects of what we're doing. I think trying to pick either or strategies is probably wrong, right? Because it assumes that you can have this binary universe of just turning off everything that we have today and going to this entirely new universe. We have to realize there's a lot of embedded things out there. And where I see the public aspect of this really helping is in that area. In other words, how do we set the rules? How do we think about our engagement to help us overcome structural problems of the assets, the systems, and the way people work today versus where we want to go? Does that mean that it's got to be the heavy hand of regulation? No, not necessarily. But I definitely think there are ways that governments and public entities can help overcome the kind of the current. Where I look at the private side of it is doing the truly transformative or innovative, which is what new things can we go create that can radically alter the equation? And I think that's where each side plays a good aspect in terms of what they do best. So helping protect and create and work around what is here, and those that are creating something new and innovative tomorrow. That's the best way I see them connecting up.
Yeah, might you say that the public sector, if you will, or society at large, really has a potentially very important role to play in setting policy? I mean, in one way, shape, or form, you would hope that sort of policy direction that's going to directly affect you and Toyota and Shell would come out of that, and that requires informing the public, being transparent in discussions about issues that will allow them to make informed decisions and guide their policymakers.
Yeah, absolutely.
Ajay, perspective on that?
No, I think nothing more to add. I think I agree with what Richard said.
All right. Or Jeff, what?
Yeah, the only thing I'll add, when we talk about policy, especially from a fuel economy perspective, we need one national program. Yeah. And I think that's the debate right now. If we allow it up to the states, we're experiencing that with automated driving right now. It just becomes a hodgepodge of rules and regulations, and it makes it more difficult to deploy new technology. So we really need to have a national program.
Yeah. Okay.
I would love to get there, but I think we're going to have to anticipate that it is going to be regional. Yeah. I'll just work with that.
Right. This one is another transportation question, so direct this one to Jeff. With respect to the different forms of transportation electrification, which forms, BEVs, FEVs, H2, fuel cell vehicles, will ultimately be dominant in which market segments and why?
Well, until we reach economy, well, obviously BEVs and fuel cell, we think, have the most promise. Toyota's been very keen on fuel cell for a long time for many reasons. Hydrogen is most effective for longer ranges, demanding duty cycles with minimum downtime, stores more energy than batteries at a fraction of the weight, less burden on the electrical grid, faster refueling, a lot of benefits there. Obviously, the drawback right now is infrastructure. There's very limited refueling stations, throughout the U.S. BEVs also have a great possibility, but they have many of the similar issues, right? We really need to have that infrastructure in place. We need some improved technology, especially on the battery side, from an energy density, just to provide greater range. And so both have a lot of opportunity, and we're very bullish on both, but there's a lot of homework that still needs to be done. I mean, we haven't even talked about recycling. And, once you have millions of lithium-ion batteries on the road, what do you do with these batteries? And right now, it's not very lucrative to recycle a lithium battery. It's very cost prohibitive, but it's an issue we're going to have to deal with eventually. So we're already studying how to repurpose, how to remanufacture, other different applications we can use these batteries for. Maybe, Rayford's power plant, we can use some of these secondary batteries. So a lot of opportunities that are being explored, but we're not there yet.
Yep. We have got about 3 minutes to close. So I'm going to offer each of you like a very short opportunity to make a final comment with regards to the topics we've been discussing. Ajay.
Great. No, first of all, thank you, Richard. I really enjoyed this time that we had together. Lots of interesting topics to debate and talk about. I think for me, the last thing I would say is that I remain extremely bullish about our industry. I believe that we have the capabilities, the knowledge, the know-how to play a central role in the energy transition. We are not yesterday's industry. I truly believe that, in my heart and my soul. But I also think that this is not a bridge too far. This is not Project Impossible. Yes, a lot of elements need to come together, but there is a clarity of vision on what we as Shell, of course, need to do, but more broadly, we as society need to be doing to be able to get there. And I'm very confident that we're going to get there by continuing to have more forums and dialogues like this to kind of get everybody onto an even playing field and just go after it. So thank you, Richard.
You bet. Rayford, how about you next? Like about 45 seconds worth of you next.
Sure, I was going to say something really quick, which is like Ajay, I see a very promising future in front of us. And the fact that we're all here and from different companies and different industries, and yet singing a very similar message, I think says that we're going in the right direction as a company, as an organization, as a society, and I'm really looking forward to it.
Great. Jeff.
Yeah, just to go back and quote our global CEO, Akio Toyoda, as I did at the very beginning, the possibilities of what we can build are endless. And I think there's a lot of opportunity. All of these disrupting technologies are amazing enablers. And it's just a matter of how we can bring these to market as quickly and as timely and cost effectively as possible, to meet customer needs.
Yeah. Okay. Well, I want to thank you three gentlemen. I think it's been a very interesting discussion. I wish we had another hour to explore a whole host of issues that we didn't quite get to cover. But I want to thank you, and I want to certainly thank the audience for their participation. And I look forward to seeing the general themes we've elaborated continue to be discussed.
Thank you.